Nah, sudah Bu, sudah nyala. Sekarang Bu share screen lagi kayak yang tadi. Monggo.
So good morning, everybody. Today, the core subject of tropical architecture is about ventilation strategies for humid tropical region. Especially, I talk about the humid tropical or warm humid region, warm humid climate. Yeah. The course objective and material today is explaining. The objective is the student can explain and analyze the design principle of tropical architecture in form of holistic precedent review. That means this is the material for enriching your knowledge to ventilation aspect or ventilation subject for doing or working your assignment. And I have to handle this lecture and 2 sessions. Today is the 8th session about ventilation strategy. The scope is our ventilation functions, climatic aspect in relation to building ventilation, and ventilation principle and design aspect applied for ventilation strategies. This means the design aspects mean the factors of ventilation strategy. And next week, the ninth session about the lighting strategy. So today is about ventilation strategies. I offer you to read 2 books. Actually, there are several books about the tropical architecture in tropical climates and about the ventilation. The 2 books I have delivered to Ibu Fenty and she shared to you today. And about the climatic condition, perhaps Bu Windy or Bu Colintia has explained about the climatic condition in tropical climate. Could you please recall the climatic condition? What is the problem for tropical climate or warm humid climate? Please raise hand. 2 of you maybe. Oh, sorry. Kursor ke bawah. Oh, only Bu Fenty.
Kenapa Bu?
Enggak yang enggak mute.
Oh ya, saya mute aja Bu kalau gitu.
Bukan.
Oh,
Enggak
anak-anak.
Oh, yeah. What is the main problem for tropical climate or hot humid climate or warm humid climate in Surabaya or in Indonesia or in Malaysia? Maybe the same climatic group or climatic climate region. Widyandini, maybe you can Tell us.
I think it's the humidity and the heat,
Huh?
maybe.
Yeah, high
The prop.
humidity and
Yes,
high
high
temperature.
humidity and the heat.
Yeah, high temperature.
Yeah, high
Because of high
temperature.
temperature and radiation is also high. Okay, thank you.
Yes,
So here Indonesia is here, and this is the equatorial area. So see my computer. Sorry. So according to some expert that offer the concept of uh, climatic responsive or climate responsive architecture, that one of the or the oldest um, oldest concept in responsive climate responsive architecture is about bioclimatic chart. The J in 1953 have introduced the bioclimatic chart that which has the relative humidity on the horizontal. This is relative humidity in the chart in x axis show us the dry bulb temperature, and this chart show us about the comfort zone. In this comfort zone, the comfort zone can enlarge here. Curves above show how air velocity or air movement can extend or enlarge, extend the upper limits of the comfort. That means if the highest temperature, highest dry bulb temperature is 30, uh, the comfort zone can be extend to uh, higher than 30 degree by uh, adding the air movement 0.1 meter per second and about 32 degree by adding the air velocity or air movement 0.4 meter per second. But in other direction, the up, the below, if the temperature is lower than 20, the radiation can also extend the comfort zone. That makes the condition is more comfortable by the 100 watt per meter square meter, 300 watt per square meter, and then the we can feel comfort in lower temperature than 20 degrees Celsius. That is the role of ventilation or air movement in the condition in tropical region. Then it is we can feel that between 22, 23, and 30, or lower than 30, it is we can see, we can say impossible that in a tropical climate, in warm humid climate, the temperature always or most of the time is higher than 30 degree outside the room or the house. Even in the house or inside the room, in some condition, the temperature is also high. Then the role of ventilation or the role of air movement inside building is very important. The next is the ultimate goal or the very important goal of ventilation is to achieve required air change rate, or we can we always mention as AGH or air change in volume cubic meter per hour or per minute, which requires spatial proportion and design developments in order to prevent old stale air, the apa ya bahasa Indonesianya, yang pengap, yang tua, yang the from remaining in the occupied zone, in this occupied zone without air movement. By ventilated the occupied zone, the stale air become changed with fresh air to enter the occupied zone of the building. Yes, that is the in traditional house we can see like this, or in a vernacular house. The house is very porous. That means there are many opening, or the entrance of the air movement is from roof material or from wall material, is from floor material, is like this. But how about the principle of the general ventilation principle for the general architectural tropical architecture? Now we come to ventilation function. There are two, actually two ventilation function. Sometimes also we can say also three. Here I just mentioned the two. First is to supply fresh air to meet the respiratory needs of the occupant. That means we need fresh air. And the second, to remove airborne contaminant. That means also to maintain the fresh air without pollution, without contaminants. It's like the recent problem here we has experienced today, recently, is about we have to open our opening or windows in houses to have the fresh air, to prevent the pollution about the virus. Is it also one of the ventilation function? And the second, to maintain the temperature and humidity within acceptable range that is appropriate to the activities on the premises. That means temperature and humidity is not combined, but have to be taken in consideration, or we consider the temperature and humidity to give the comfortable condition for human activity. That is for comfort. The second is the first is to give the fresh air inside the room. So then how we can provide the fresh air in the house or inside the building or in the room. To ensure air movement. First, to ensure there is air movement in the building by creating pressure differences into what we call it principle. First, we call it wind-induced air movement or wind pressure. The second, the pressure is created or generated by temperature difference or temperature, we call it temperature-induced air movement. So for the first principle, we consider the wind direction and wind velocity. The wind direction and wind velocity is the most important aspect to create the pressure. And for the second principle, we consider the temperature difference to create the pressure. So, now we can talk about the wind-induced air movement. In wind-induced air movement, we consider the wind direction come from the windward side and leave the building. We call it the opposite side as leeward side. So wind pressure distribution. Okay. Ini cara. Siapnya 2 minggu ya, 1 minggu atau 2 minggu. Tapi saya dari jauh hari sudah coba. Saya bilang udah baru bilang begitu besoknya keluar surat. Okay. According to the wind, the existence of the wind in the climate, wind direction and wind pressure, wind direction and wind velocity is the aspect of the climate condition, climatic condition. I'm sorry. So, wind is a climate aspect influencing ventilation. Wind velocity increases with the height of the building and is reduced in built-up areas because of the urban canyon effect. We can say if the meteorological data present wind data, the meteorological data recorded in the in the meteorological session that provided in near airport area. The condition of the airport area is in the open country. We call it open country in 10 meter height. So like this. If the meteorological data said that the wind velocity is 5, we can calculate or predict what is, how about the, sorry, yeah, the velocity in city center or urban area. This urban area, the characteristic of urban area is like this, and the city center is more dense, and there are many high-rise building. Then the velocity is lower in the city center. Here we can calculate it form 5 in the meteorological data record. In urban area 3 meter per second, and in city center 1 something. The velocity is lower and lower and lower. Then you can not rely on, if you design in the city center, you have to predict or to measure the real condition of wind speed in microclimate, the local climate or microclimate. Only isolated areas allow for the utilization of the full meteorological wind speed. Yes, if the building in isolated area, only one building, freestanding building, then we can use the meteorological wind speed recorded by meteorological station. Yeah. Komputer saya itu gimana sih? So, sudah, anu semua keluar semua. So, wind pressure mechanism. Yeah. The wind come from the side, and here the windward side, here the leeward side. That means the pressure difference is very high. Here positive and here negative. And here is also above the building is also negative. That means if we here is plan, here is action. If we have opening in this windward side and leeward side, then the air movement flow from this higher pressure to lower pressure. Here is also negative, is also negative. That means the wind flow from the higher to lower, or from the positive to negative pressure. Here's the books, this said that high pressure area, pile up of air that is higher, go to the highest press the building, and that is the high pressure here at this position. And here for the there is a partition Blanketing of breeze, that means menyelimuti bahasa Indonesianya ya, menyelimuti of breeze, creating pockets of warm still air. Warm still air or stale air, that means the warm condition inside the building cannot freely freely move. That is there is a uncomfortable area. So now about the arrangement of the building, we can learn. Oh, the connection in unstable. Traditional Malay house, as an example, the left, randomly arranged. That means it takes advantage that the wind can freely flow between the building or the houses. This ensures that wind velocity in the houses in the latter part of the wind will not be substantially reduced. That means take the advantage of the scattered position or scattered arrangement. When we see the other side, the rigid pattern in the arrangement of housing estate, houses create barrier that it can block the passage of wind to the houses in the latter part of the wind. That means the back side of other side of the building will be blocked by such arrangement. So now the vertical element. The role of the vertical element or wall or fence can direct the air movement. Oh, air movement. If we design like this, that is the opening, and here the fin. We can say that the fins are like room, small room, but that is the vertical perpendicular to the opening facet with openings. The other outrigged rooms can form wind foils. That means to promote or to direct the wind. Other fin position, that is fin, the fin position can help us to create the pressure difference. The pressure difference like positive, negative, positive, and negative. If like this is that is too small. As an example here, if the wind from here, that is the positive, here is negative, then the flow is like this. But if the position you can see here, the position is here and here. But if the position here and here, like this, here positive and here positive, that the air move there is no air movement inside the building. Then we have to take a consideration to about positioning the fin on the facade. And here we can see the best condition, good, poor, or here's also poor. We can see here the distribution, the effectiveness of the natural ventilation occurred when the flow of air movement is distributed evenly in the building, inside the building, inside the room. If you see these rooms, this room, this room, and this room, and this room, there are no air movement. Then please pay attention in the positioning the fin. So what we have discussed is about the what is the principle, the first principle. What about the first principle? What is the first principle? I'm sorry. Wind-induced wind-induced ventilation. The next is about the temperature difference or stack effect ventilation. So we can direct the wind flow or wind or air movement by designing the landscape or designing the vegetation, but it is we have to be careful to choose the what kind of vegetation of what kind of vegetation of what kind of trees. If you choose like this, that means the tree is like a palm tree or coconut tree like this. If you draw or do you choose like this, then it's like shrub or for dense leaf to protect wind or to direct the wind. Now the other aspect to create to direct the air movement is what is the fenestration or window element. Here we call it a window element and on the facade by positioning the louver like this or like this. Then we can remember what is the function of the ventilation. If just the keep the fresh air to exchange the room stale air or odor or pollutant like this is okay. But if there is the function or we set the function as comfortable ventilation, that means the airflow should heat or flow to human body. Actually, it is better if I set a human here to give the too easy to remember that the function is state here. Then the overhang, the type of overhang also influence the movement of the air. If the compact to attach to the wall directly, then the flow is like this. With the position in the opposite side is at the top near the ceiling, and the second side is like this, and the third side, the third kind of overhang is like screen, like screen. The distribution is better than this one, and the best comparing the two other kind of overhang. But to ensure the cross ventilation, the higher up windows to allow hot air to escape. Hot air or stale air is like this. It is better. And to create a smaller inlet window facing prevailing wind and larger outlet window on opposite side. So that is all we discuss here is about the component or aperture in the facade. Now, what is the form trigger of the form? Cross ventilation is often combined with a stack ventilated atrium. I explain after this about the stack ventilation or temperature different pressure generated by temperature difference. To increase building depth, to increase building depth and coordinate with daylighting and circulation strategies. That means integrated strategies between ventilation and daylighting. Like this is the atrium. Then the cross ventilation occurs like this. Now we come to the temperature difference, not pressure difference generated by temperature difference. If we remember the principle like this, the warm air rises up and the cooler air flow from lower side of opening of the building. We can we can say that the stack effect ventilation either there's chimney effect ventilation or buoyancy effect ventilation. When outdoor temperature about same higher and or same the indoor temperature, the stack pressure differences are going to be small and will be much lower than wind-induced pressure difference will much lower than wind-induced pressure differences. That means we can not perceive the movement, just rising up the flow, but we cannot perceive it. So the summer ventilation based on stack ventilation can only be utilized if the upper stack here, the upper side gets really hot. For example, through exposure to solar radiation, or we choose, we applied here the material that can make this part hotter to create the more airflow to rises up. That means entropical or hot humid tropic, where the temperature difference between outside and inside is like this. The flow of stack pressure, stack effect ventilation is cannot be perceived. An atrium can also act as a solar chimney if the top of the atrium extend beyond the roof line. Here is not just like this, but extend beyond the roof line of the building and provide additional solar exposure. That means here this solar exposure. That is the role of the atrium to create or generate the stack ventilation, stack effect ventilation. So the pressure differential active at the inlet here has to be strong enough to overcome the friction of air moving against the material and geometry at the ventilation inlet opening area. If the temperature outside and inside, the difference is large, then the flow can be, or the air flow or rises up. But if there is no differences or in this balance condition, then there is no flow inside the room. That means this picture like this. So about the temperature difference, 3-story buildings, approximately 10-meter height, the difference between indoor and outdoor temperature should be about 23. It is impossible if we have in the tropic. For 8-story building, should be 10 degrees. In summer or tropical climate, stack ventilation strategies are combined with wind pressure. It is impossible if we rely on only on the stack ventilation to create air movement sufficient for comfort for achieving comfort condition. Combined with wind pressure in order to ensure required air exchange rate or velocity, sorry. The other rule of thumb, the stack outlet should be at least half of, that is the outlet, half of one story above the ceiling above the ceiling. That means here, one story is here. This equal than one story. So, sorry, one story above the ceiling level of the top. That is why we mentioned as a rule of thumb. That means come from the experience or research result that conducted before. So the other consideration of ventilation or the use of ventilation, experimental roof, that is also our ventilation experience or ventilation research. The adequate air gap between two material of the roof is used or should be provided to have the role as insulation. That is prevent heat from the roof to the occupied zone. So now we can come to the summaries. The ventilation principle is the first what we have to remember is to create pressure difference for ensuring air movement. The first principle is wind-induced air movement. We always think about the wind condition in the local climate. And the second, the temperature-induced air movement or temperature difference. We always think about the temperature difference, how we create the temperature difference, and so on. All the principle, the ventilation strategies, we consider the building shape. If for the cross ventilation, what the building shape should be. For the stack ventilation, what kind of building shape. And building orientation, actually we have to concern about the position of the facade with opening, how we orientate the facade to have the wind come into the building. And window or opening size, window or opening position with opening size, opening position, and the use of mechanical means. Just mechanical means, I have not yet said here. The mechanical means we can consider like this. if we can, we mention or we have idea to promote the air movement with the cross ventilation, we can use the principle of extract ventilation. Means we use or we install the exhaust fan to pull the air movement to create to higher the movement velocity, or give the exhaust or positioning the in-house fan to also to pull the air movement from outside. That this extract ventilation means to promote to make the, it's like force ventilation, yeah, to make the movement higher velocity. So I think that is all. If you have question, please raise hand. Yeah. Any question or you have any idea? Nggak ada, Bu Fenty. Any question? Rida Putri Nabila yang kelihatan di sini. Indro. Oke. Kalau nggak ada Bu Fenty, I think that's all. And next week I will before we have the session, I will share one or two texts to prepare and to prepare for discussion before or after my session about the lighting design or lighting strategy, or about this strategies or this subject, today's subject. Siapa kayaknya Widiandini mau tanya ya?
Ma'am, Ken wants to ask question in the chat box, ma'am.
Oh, oke. Bisa. Oke, please.
No, Ken, ma'am, not me. Ada Ken di chat box.
Ken.
Ya, ada Ken bertanya.
Di sampingnya share screen itu, Bu,
ada tulisan chat.
Iya sih.
Atau Ken bisa pakai ini nggak? Itu kayak mute-nya udah mati deh. Ken langsung ngomong aja.
Hello?
Ya, halo Ken.
Check.
Ya, masuk Ken.
Yeah, I have a question about, I think air is vital for human or user life.
Bentar.
Okay.
Agak nggak dengar. Sudah lower hand, ya. Chat, Anda sudah ngirim chat, Have you written in the chat?
Yes, I did. Yes, I did.
Kok nggak kelihatan ya, Bu?
Di sampingnya share screen itu, Bu.
Itu mesti
Ada tombol chat, sebelahnya record.
biasanya kelihatan kok. Ini
Oh, di ini Bu, di full screen-nya. Nah, oke.
Chat yang partisipan ini bukan?
Sampingnya partisipan, Bu. Samping kanannya itu ada share screen, samping kanannya lagi ada chat.
Iya, biasanya ada, ini nggak kelihatan. New share langsung. Pause, share. Noted. Ya gini nih loh, Bu. Turun apa?
Oh, saya bacain aja, Pak, Bu. Atau Ken ini udah?
Ya wes, ya gak apa-apa.
Ken aja udah, Ken. Iya, Ken. Langsung ditanyain
aku
aja.
pakai ini aja ya.
Iya, Bu. Nggih, nah.
Iya, karena kadang-kadang gemah itu nggak jelas ya.
Iya, Bu.
Sorry. Yeah. Okay. Please.
Okay, is it good, ma'am?
It's good.
Okay. My first question is, how do we calculate that the amount of the air is enough? And what is the parameter?
Okay. The parameter, yeah. For the calculation, so, and for the level, I mean, for the undergraduate student, we have to you need to have the rule of thumb. Maybe I have to tell you more of the rule of thumb or experience research result from other researcher to what I tell you before is all the rule of thumb or the principle, the research result that has written in the book. Then for the undergraduate student have not don't have to calculate. But if you need a calculation, that an example that I have told you about the wind condition or exchange rate or volumetric rate of the air movement, I can tell you in other session or for this class, maybe I can attach or share some equation for that. But for the design, for your design or for your idea to design your building, it is enough if you take another. You learn from this book, from that book that I show you, I share to you another principle, another principle, the principle or strategies, and you apply in your design. The parameter is window the variable is the volume, window area, and wind velocity, and so on. Then that I don't prepare for this calculation, but if you can sometime because the air to calculate the ventilation rate or ventilation wind movement or air movement is apa namanya ya not as it is more difficult than thermal about the thermal. Maybe Bu Windy show you about the calculation of the thermal or the heat transfer and so on. For the ventilation, we have to adopt to apply the fluid equation or fluid theory that is more difficult because the principle of the heat transfer and fluid untuk aliran itu, air movement, there is some, but I can tell you about if you need this.
Bu Nastuti, sebenarnya kan saya ada ini website, saya klik di ini ya, di chat itu. That website is developed by my previous university. You can check if you want. Ini kayak ini Bu website buat simulasi tapi simple banget Bu. Jadi mereka nggak harus tahu yang detail-detail. So this is the simplest way to understand whether your building has a good ventilation or not. Saya sudah chat di situ. Semoga masih bisa ininya. Soal profesornya yang bikin kebetulan untuk undergraduate students.
Ya, memang ada di buku yang bertuliskan bahasa Indonesia. In book Indonesian version fisika bangunan itu yang ditulis Pak Prasasto itu juga sangat sederhana. Memang sangat sederhana. Jadi window area times so is it enough or not? But sometimes architects design complicated form and shape, and the window position is like this, so and so on. Then it is as complex. But if you want to have the calculation, I show you the book. Yang simulasi Bu Fenty kirim itu apa namanya kayak worksheet gitu ya. Tinggal ini masukkan gitu ya.
Iya Bu, ini Bu, saya boleh share screen nggak Bu? Ini.
Boleh.
Iya.
Untuk semua sekalian.
Ya.
Ini saya stop dulu.
Ya, stop dulu. Share screen-nya.
Oh, ini kilo.
Di atas Bu.
Udah, lama.
Oh iya, saya tunggu aja.
Nah ini udah muter-muter, udah.
Oke.
Ini tadi harusnya di restart dulu, habis dipakai
ya,
dalam waktu lama.
Oh, ternyata ini juga bukanya. Sudah. Sebentar. So this is how it looks like.
Belum kelihatan ke saya. Enggak apa-apa, terlanjutkan.
Oh, sudah kelihatan, Bu?
Belum.
Oh, belum. Oh ya, saya
lanjutkan aja nanti.
Can you see this? All of you?
There's nothing. Just a black screen. Oh yeah. Yeah, it's already.
Okay.
Yes, ma'am.
Okay. So this is called natural cooling of the vent. Sekarang udah masuk yang kedua. So when you click on that link, you can find this and you will go to this website. This is internet connection is not that good.
Saya kira sudah ada ininya, apa contoh perhitungan.
So basically, if it is open, then you can find several scenarios, whether you can choose single side, and then single side like this, and then double side, and then stack ventilation like this. And then it will provide you, actually in my phone it's already open, but I
Oke, sudah barusan buka ini.
Iya.
Optivan.
Iya, Bu.
Ya, ini untuk desain
Jadi,
memang. Jadi bukan.
Ya, ini you can just choose one scenario of it. Why the internet is so slow? I will share my image here. I've already taken a screenshot in my phone. Jadi intinya kalian kalau mau desain, kalau yang Bu Nasiti maksud itu memang untuk jenjang berikutnya itu sangat complicated ya Bu. Maksudnya banyak parameter yang harus dipertimbangkan dan itu belum istilahnya belum kapasitasnya seperti itu gitu karena kalian masih berfokus pada desain. So for undergraduate student, I think this is the best way to understand. And if you are really into like calculating stuff, itu ini yang paling bisa digunakan. You can choose between this one, single-sided ventilation. There are two like this, and then double-side natural
cross ventilation, single-sided ventilation, cross ventilation, and stack ventilation.
This single, this ventilation.
Itu yang dimaksud. Boleh dicoba.
Ya, Bu. Ini mau, saya klikkan tapi ternyata lemotnya nggak karu-karuan, Bu.
Iya, sama.
So I will share, I will share the image that I got here. Then you open that one. Bentar. Ini dia. Oke. Nah, so this is how it looks like. Kelihatan nggak? Kalian, can you see this?
Belum, Bu. Ya, ini sekarang sudah.
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 Nah, so you can choose whether it is single-sided ventilation or cross ventilation, and then atria ini yang, and then chimneys. Kalau atria itu atrium kayak gitu. Nah, nanti itu you have to input several data, like what Bu Nastiti said about the window, about the walls, about the size of the window, and then the room as well. Jadi masih harus memasukkan beberapa data basic yang di sini.
Kecepatan anginnya juga ya, Bu? Pasti
Iya,
ada.
kecepatan
Pasti
anginnya ada, tapi basic banget kok Bu.
Iya, nggak apa-apa untuk melihat.
Kemudian, for example, we can try the single-sided one, and then you can see here there are several, for example, project location. Oke, sebentar saya ganti screen saya. Nah, so this is the first look of
Ibu
this.
sudah, saya belum.
You can choose. Oh ya Bu.
Gak apa-apa. Lanjutkan aja. Anak-anak sudah lihat.
Have you seen this page?
Which one?
Anak-anak sudah belum? Adik-adik sudah belum lihat ini? Can you see this page?
Yang isinya 4 kotak itu ya? Yang gambar?
Iya, Bu.
Iya, ya itu. Iya, memang itu.
Optivan. Iya, oke. Nah, from this, you can choose which one you want to use for your building. Usually in Indonesia, we use cross ventilation, like Bu Nasiti said. Seperti ini, cross ventilation simpelnya. When you click here, there's project location. Jadi ini.
Yang itu yang nggak bisa dilihat, Bu. Yang klik here, klik.
Udah, Bu.
Masih 4 kotak yang ada single sided, ada cross ventilation, ada chimney sama stack.
Okay.
Gak apa-apa, lanjutkan aja.
Yeah. Okay, if you can try, you can find the project location tab, and then you can input everything about the project location. This is important as well, because when you try to simulate everything in science, then you have to be based on the location. Nah, ini ada latitude, the latitude, latitude-nya kalau Surabaya itu 8, antara 7 sampai 8.
7.
7 ya, Bu ya?
Yeah.
Terus kemudian bulannya. Jadi ini tuh, jadi kalau di simulasi itu ada yang there are two types of simulation, dynamics and static. Nah, this one is a static one. Jadi dia itu spesifik pada waktu tertentu. It's only used in a specific time. So you can.
Some books said that the static is a steady state.
Yeah, steady state. Betul. And then you can find here the time. You can input the time, and then the wind speed. Nah, wind speed you can find it in the Google. Itu ada datanya, ini penting. And then the orientation of the surface atau your building. And then you can find this one. Nah, ini. Jadi you need to put the outdoor and indoor temperature, tapi biasanya yang umum aja sih. Kalau kalian lihat di sini ada gambarnya juga, ada diagramnya. Sudah sih, Bu. Nanti itu hasilnya akan keluar ruangannya itu, ruangan yang kalian hitung itu nanti sudah memenuhi standar. Iya, jadi bukan ininya, tapi cuman standar yang digunakan di sini. Kalau ini kalau nggak salah LEED yang dipakai. Oh, SIPSI. SIPSI itu punyanya UK. So the standard used by this website is SIPSI guide from UK government. They will given you a report the wind speed in the room, but not like very detailed, and usually it is comfortable or not, just like that. So it's very simple. Sudah, Bu.
Oke, saya lanjutkan sedikit penjelasannya Bu Fenty tadi. Memang tadi itu memang kita nggak mempersulit ya. Jadi makanya S1 hanya menggunakan prinsip-prinsip to use the research result that has Bu diformulasikan formulated for design. Then you can apply according this principle or this design you conducted by by previous researcher like this. But it is appreciate. I appreciate that you have interest to learn more. That's okay. Then actually in our laboratory is also trained. The member are trained the simulation for sustainable architecture. Also, like Bu Fenty said, that is a principle. What is that? For the designer, not for a researcher. That is, if you choose the material like this, if you choose the room shape like this, then how is the energy consumption? How is the lighting condition? Is the ventilation condition is like this? But you can also learn in the we have just used or we have just teach in the postgraduate magister design. Oh, magister perancangan. Magister architecture.
Yeah, magister
architecture sampai lali. Magister architecture. That the program the simulation program is licensed, then masih dalam percobaan dulu, is still trial, and that is not yet apa namanya disebarluaskan. Jadi hanya khusus untuk apa dulu, apakah untuk di magister atau S1 atau apa. For undergraduate is not apa namanya, all topic related to the energy consumption. Then we have teach the magister architecture student like this. If you have interest on that kind of thing, I with pleasure I can show you this program. Itu Bu Fenty.
Oke, Bu.
Yes.
Sudah saya jelaskan di chat juga.
Iya, aku gak nemu chatnya mana. Nanti tak cari. Kadang muncul kan. Oh, ini apa?
Ya, chat.
Iya. Oh, gak nangkep itu. Ada lagi yang lewat chat? Ada lagi yang lewat chat?
Kan itu nanya 2, Bu. Satunya itu tentang buoyancy effect itu loh, Bu. Itu kan dia nanya, what is the relationship between room shape, volume, and buoyancy? Kemudian saya jelasin lagi bahwa buoyancy itu sebenarnya air movement yang tercipta karena ada perbedaan temperatur. Iya. Jadi ya seperti yang dijelaskan Bu Nasiti tadi, bahwa itu sebenarnya, jadi sudah saya jawab,
sinonim.
Bu nambahin aja.
Sinonim. Kalau dalam bahasa Indonesia gaya apung, pernah saya ini kan di S1 waktu itu. Gaya apung itu buoyancy itu. It generated by temperature difference.
Yeah. Ken, gimana Ken?
So it's true that room shape doesn't affect air movement as long as there is a different. As long as there is a different air pressure, there is no.
Oh,
ya,
paham Bu. Room shape itu mempengaruhi. Silakan Bu.
Mempengaruhi. Coba, gimana nih?
Dijawab aja Bu, langsung enggak apa-apa.
Oh, oke. Ya, the room shape. Room shape influence the air movement. Not the air movement not only the air movement, but the air change, volumetric air exchange rate. That is because there is a research result that the rectangular, bujur sangkar itu apa Bu? Rectangular and
rectangular.
Satunya lagi persegi panjang. Ya ampun, tiba-tiba lupa.
Ya nggak apa-apa Bu, pakai bahasa Indonesia aja.
Persegi panjang dengan bujur sangkar, rectangular and tiba-tiba lupa.
Square.
Square.
Kotak Bu, bukan?
Ya, square yang bujur sangkar, rectangular yang panjang ya.
Iya.
Which is panjang, length and width is not the same. Length and width. If we call it rectangular, mean we have four sides at the same length. Is it okay? The shape will influence the pressure distribution in every side for long rectangular, and for the apa Bu yang bujur sangkar tadi sampai lupa lagi.
Rectangular sama square. Square.
The square.
Ya.
Bisa saya ini kan dari ini ya gambar. Nggak usah. Pokoknya itu mempengaruhi perbedaan pressure di sisi-sisinya itu. Nah, itulah kalau kita buka opening in the facet on the facet that has different pressure. The difference of pressure difference the pressure difference apa ya nilainya? The value of the pressure difference is higher than result the exchange, the different exchange also. That means your question affect air pressure really and the air movement. Ya, kan nggak bisa nunjukkan ini, nggak siap gambarnya.
Circular shape is has better. Ada pertanyaan lagi Bu dari Berliana.
Yeah.
Itu is a circular shape has a better air movement than a sided form. Circular shape has a better air movement. Yang agak di atas Bu, 1055.
Agak di atas.
Sebelum saya jawab.
Kan?
Circular shape.
Nah ini. Mana nih?
Yang Berliana itu.
Circular shape artinya melingkar ya?
Iya.
Has a better air movement than a sided form. Ya, dalam hal meratakan. If you have a sided form or rectangular or quadrat, that means there are bebannya di tiap-tiap sisi itu nggak sama ketekanannya. The pressure of the side, every side is different. But if you have tekanan, if you have circular shape, that is like the apa Bu? Kalau mobil itu
velocity Bu.
Bukan mobil yang bentuk mobil itu harus apa? Harus gimana? Kalau pesawat juga yang
aerodinamis.
Iya, aerodinamis.
Nah, itu sisi-sisinya itu akan mendapatkan tekanan yang enggak jauh beda gitu. Jadi ininya
mungkin yang perlu ditanyakan lagi maksudnya Berliana ini di dalam apa di luar ya Bu? Circular shape what do you mean has a better air movement, inside or outside or inside outside? Atau inside?
Dia nggak ada, cuman circular shape has a better air movement.
Berliana gimana nih? Berliana
bisa
ya
betul.
Inside ini maksudnya dari luar apa luar ke dalam? Inside and outside. Oh dari dalam keluar berarti. Maksudnya dari dalam ruangan. Mana sih Berliana? Can you speak? Karena kalau diketik ini agak membingungkan kalau pertanyaan kayak gini. Berliana.
Unmute dulu. Air biasa. Untuk nyempot anggrek. Berliana unmute bisa loh.
Iya, Berliana.
Lagi meninggalkan tempat.
Kalau
ada lagi yang tanya nanti inilah.
Ya, nanti ini aja.
Hello, ma'am.
Nah, ini dia. Ya. Please.
Inside and outside.
Usually I have some books, and the circular shape has a better. It is said that a circular shape has a better air movement better than a sided form, and then why is that?
Alasannya sih seperti yang Bu Nasiti bilang tadi. Cuman maksud saya tuh gini, mungkin buku your book mentions about the exposure of the air movement, exposure dari kulit luarnya itu baru ini persebarannya sama. Tapi kalau kamu maksudnya adalah ruangan yang di dalam circular shape itu
kita lihat posisi bukaannya ada di mana.
Betul. Jadi tergantung sama bukaannya. apakah dia nggak bisa lebih baik daripada kotak kalau ternyata bukaannya juga nggak tepat di mana posisinya gitu.
Kalau kita ngomong baik enggaknya, kita lihat ini macam-macamnya itu. Tapi cuman kalau apakah itu membedakan ya? Apakah ini seperti pertanyaannya Ken tadi, memang beda yang bujur sangkar sama persegi panjang aja gitu. Ada yang perbandingannya 1:2, ada yang berapa banding berapa, itu ada lagi. Dan makanya kalau saya memberikan banyak, ya banyak sekali memang. Tapi nggak apa-apa, nanti kalau di ini kan bisa saya jawab, nanti saya jawab di sini.
Oke.
Kalau ada gambarnya juga akan saya tunjukkan gambarnya. Atau ada bukunya, saya tunjukkan bukunya.
Oke.
Ada lagi?
Mungkin ditanyakan. Saya cek.
Ini kalau jawab chatnya, ini
diketik aja di situ.
oh.
Tapi yang dipastiin tuh yang atasnya itu to everyone itu, Bu.
Nanti saya lihat lagi. Kan ini terekam ya Bu Enti ya, tetap di sini.
Bu. Iya, kalau Ibu nyalain yang itu kotak-kotak chatnya nanti.
Oh my God, can you look at this one?
Apa?
Hah? Kenapa, Ber?
Apa?
Kepencet. Berliana? Oh, kepencet kayaknya, Bu. Ada lagi yang
siapa
jalan?
Siapa yang berdiri di tepi jalan?
Rumah saya pinggir jalan, Bu. Jadi ada motor kenceng lewat itu kedengeran.
Oh, Bu Fenty.
Iya, betul.
Kalau nggak ada,
ya, Bu.
nanti, tugasnya diasistensikan ya, Bu ya?
Tugasnya belum
diturunkan, toh?
Sudah. Saya nggak tahu ini
sudah dievaluasi pertama sama Pak Teddy kok, kalau nggak salah ya, Beliana Widian ini.
Siapa ini ketua kelasnya ya? Bahasa bukan?
Siapa ketua kelasnya? Aku nggak ngerti.
Malah nggak masuk ini Bahasa kayak.
Iya, Bahasa Bu. Bahasa Bu.
Oh.
Nggak ada ya? Tugasnya sudah diluncurkan ya tugasnya?
Halo.
Ayo. Siapapun aja jawab terserah.
Tugasnya biasanya diluncurkan sama Pak Teddy, Bu.
Loh, iya, sudah belum? Belum ya?
Pak Teddy biasanya ngechat saya belum sih, Bu.
Oh, iya.
Yang review pertama itu apa? Ujian tulis ya?
Oh, ujian tulis, Bu, itu iya.
Oh,
jadi belum nanti tugasnya. Kalau nggak salah nanti minggu setelah minggu keberapa gitu nanti ada tugasnya.
Oh, memang tugasnya pendek ya. Umurnya pendek.
Oh, ini tahun ini nggak desain lagi soalnya, Bu. Kan esai.
Oh, esai. Oke. Wes banyak yang bisa dibaca. Nanti kalau ada jurnal-jurnal tak tunjukkan biar nyari sebatas yang dipahami oleh S1.
Iya.
Desain yang sudah ke desain variabel desain aja. Nggak usah sampai penelitian sing jelimet.
Betul.
Are you okay? If there is no question, then finish for today.
Iya, Bu.
Berarti nanti kalau mau share
videonya,
teks atau apa gitu?
Oh iya bisa, Bu.
Dicantolkan di classroom juga. Ini kita masih belajar ya. Jadi ini Bu Fenty yang sering banyak kuliah ini sudah dipakai classroom, pakai ini. Bu Fenty has more experience than.
Kebetulan aja Bu ini. Iya Bu, nanti bukunya yang Bu Nasiti kemarin WhatsApp ke saya, tadi pagi gitu. Itu sudah saya upload ke classroom, nanti Bu Nasiti cek lagi sudah ada, jadi adik-adik bisa download.
Oke. For all students, you can learn from the book. There are many pictures.
Oh iya Bu.
You are very very happy if the books contains many pictures.
Iya betul. Ada banyak tulisannya. Ya.
Oke.
Nanti Bu Nasiti itu recordnya nggak usah di stop. Nanti waktu end meeting nanti otomatis dia kayak convert gitu. Terus nanti tolong dikirim ke saya.
ngirimnya gimana?
Oh, nanti Bu Nasiti bisa via email atau WA kayak Pak Bambang kemarin WA saya kalau Pak Bambang.
Oh, oke.
Ya.
Ya, nanti coba saya lihat.
Oke. Ya.
Banyak gangguan suara tapi nggak apa-apa.
Iya.
Oke, thank you.
Yeah.
Thank you for all and good morning.
Good morning, Bu.
Morning. Thank you, ma'am.
Thank you. You're welcome.
Thank you, ma'am.
Thank you. You're welcome. And meeting itu mana? Oh ini.